Welcome everybody. I'm here to tell a story of Koronavilkku and how we managed to get it together in the brief time and some stories behind it. I usually like to start with a story, and this also starts with a science fiction story. You might have heard sometimes about time traveling, and this is a time traveling story of me going back 1 year from now. So if I'm going to meet myself in January 2020, it might be a meeting maybe a little bit like this. Of course, that was a year ago, and we didn't know any of those weird things we are going to have in 2020 and also 2021. The future was still bright and everything looked great. But as usual, saying goes, if I would have said myself something, for example, in this case, if I would have told myself that in a year we will have made an application which has 2.5 million users in Finland and is one of the top applications in Finland being used, it might be that I wouldn't have believed myself. But still, here we are, and this is how we have the story of how we have reached this point. Before I start, I would perhaps like to tell you a little bit about digital contact tracing, because this also is not any old thing. It's rather new invention that was started at the end of last year, and actually it was created because in many cases because of this current pandemic we are having. So the decentralized privacy-preserving proximity tracing, which all these clips from the Wikipedia are showing, that's the main point behind the Koronavilkku and other exposure notification programs. We haven't invented everything by ourselves when making this. Instead, we have been standing on the shoulders of giants and using the previously created inventions, which are giving us an opportunity to trace people and their movements and their contacts, but still preserving all their privacy. The DP3T was created by European universities, and it was used as a basis for exposure notification API, which is usually called EN, sometimes also GAEN. That was created by Google and Apple, and it was created in beginning of 2020 when people started noticing that the pandemic was spreading and something had to be done. There has been many kinds of notification software and tracking software, but many of them faced many different kinds of problems, for example, with compatibility and users' privacy. And one of the big problems was that when using as an application in smartphone, it usually is a problem because the smartphones like to save battery, and it means that they really don't like applications that are on all the time and on doing things all the time. Usually it causes problems if you are trying to create software that is scanning your environment 24/7. Instead, Google and Apple decided that they will be helping the development work so that they are creating the API, which is installed into all the Android phones and all the iPhones in the world that are newer than certain level. Usually all the phones that are created in 2016 or after that are compatible. And all those devices in the world received the update from Apple and Google in last May, which meant that all the devices are ready to be started used for exposure notification. It still doesn't work automatically. It requires software from each country, and in Finland we started making the official software for Finland that is using the EN system. But this is the technical background behind it all, and which is making it's possible for us to create these kinds of programs. Currently, the ENS exposure notification system is most widely used tracking solution in the world. So majority of countries in the world are using it. For example, here is the current list of European countries that are using the tracking exposure notifications based tracking. There are some like lone riders still, which are using their own system, mainly, for example, France in here, which are doing their own invented software, and Sweden, who don't have any kind of application at all. But and then there's Hungary, which have created their own solution. But most of the others are using the EN-based solution, which means that they are using the same Google and Apple background service, and they are also compatible with each other. They are able to exchange information between each other and like communicating between each other. Also in USA, this has started spreading. It was rather funny that the thing EN system was invented or created by Apple and Google in California, but California itself didn't have their own application until December 2020, just a month ago. And as you can see here, many of the US states are still starting to use this kind of software, but it's the Europe where we have been most advanced with this one. So as said, we received the task of creating the Finnish version of the software with the public tendering from DHL last June. And we heard about winning in the beginning of June, and there was some bureaucracy related things, and we were able to start working with that in right around Juhannus, which is at the end of June. Pretty soon we heard that our goal was to have the application ready by at the end of August, which was publicly told by ministers in TV, which meant that that was our actual deadline that was set in stone. So it meant that we had 10 weeks to create the software during the summer holiday season. And then there were many other technical little details. I'm telling a little bit more about those later. But it meant that in 10 weeks, as many of you who are working in the business know that this is rather short time for creating software, but still we were able to make it. And what does it contain? Actually, in the beginning of the project, many of the people contacted us or in the social media and otherwise told that, okay, this is not a problem. It's just a small, simple application, and it has been done elsewhere. So it's a piece of cake of doing that. But here, as you can see, it's not that simple thing, actually. What we did in this project consisted of many different parts. So the main thing that most of the people see are, of course, the two native applications for iOS and Android called Koronavilkku. But in addition to that, we also created the backend database, which is the national version hosted at Kela. There was a decision not to host anything outside Finland. And Kela was the third party that was willing and able to host the backend database, which has rather high traffic, of course, but they have experience of hosting services that most of the Finns are using. So it was quite self-evident solution for that. Then we created pinned code generator that is used by healthcare professionals who are giving the positive coronavirus infection result for the persons who would like to share their infection. In the beginning, it was used by 600 healthcare professionals. Now the number is much, much higher. It's between 1,000 and 2,000 people, last I heard, and it's growing all the time. All those people were, of course, trained and had access to it and were able to start using it. And then what happens after when people are getting the infection warning they are given instructions and the way forward to communicate with healthcare professionals. That was integrated to omaolo.fi service, which also created in background. So these 4 parts were the main programming things which we created. The native applications were actually the simplest ones because they were based on EN code, and we were able to utilize the source code from other countries who have also been creating such services. But the 3 other solutions, they are national for Finland, and they were creating for just for Koronavilkku, and we came from the 0 starting point for these. We had 2 testing phases. First one was internal, showing here it in the photos, and the second testing phase was with 2 of the largest hospital districts in Finland, from Tampere and Helsinki. And of course, we had user testing for other users too. We did user interface design for the whole thing, and one of the big things that was going on all the time and is still continuously going on is the cooperation with many different parties. Of course, with Apple and Google, who have created the EN API, but we also have a community of all European countries who are creating an EN-based solutions, and we are in constant contact with them. Then we have European Union e-health network that is doing the coordination for the back-end synchronization between countries. And of course, the local players, DHL, STM, Sotedigi, who have created Omaolo, and so on. So there were many different groups of people communicating and lots of meeting, of course, but everything went very, very smoothly. There was very good spirit between all the participants, and it's like everyone was helping each other, and we had the global working together mentality. All enemies, Apple and Google, are working together, as are all the different countries who are instructing and giving advice to each other, and so on. As were we, of course. For example, we in Finland have been giving information for many different countries throughout Europe and world, and like sharing our experiences and teaching them, and so on. Then we had audition, because the privacy and trust is very important. So we had the local NCSC, Kyberturvallisuuskeskus, who audited the whole thing and found out that it's very secure. And then the public was also very closely working with us. We gave white hat hackers invitation that should they want to contact us and take part of the development and give us good hints and so on. And they were very, very glad to cooperate with us. And of course, everything we did was published as open source, so all the public is able to take a look at this and see for themselves that it is very trustworthy and reliable software. And they can see how it is made and see about that one. As said, all of this happened in 10 weeks, and we also let people have their ordinary summer holidays as before, which meant that this was rather busy time, but we still managed to do that. And we had some surprises. For example, Apple and Google thought that when releasing this into App Store, there will be extra tight security and auditing with this one, and we should reserve 2 weeks for the app review, which meant that, okay, we just had 8 weeks for the programming, but still, that was what we were doing. The little known fact is that Koronavilkku is not the name we started with. The name changed in the middle of programming. The minister wasn't happy with the original name, which was Koronavilkku, and it had to be changed, which means that when you are looking at the source code or app stores, for example, Google Play stores, you might find the name Koronavilkku here and there. It means that that is the original name for it, this one. And we were able to release this from the day we promised without any delays at the deadline. So we are, of course, very proud of this one. Everything went smoothly and just like designed, and we were able to create it. And of course, happy about that one. couple of words about background with this one. I'm not staying quite long with this one because most of you already know how Koronavilkku works. But again, if there are still people who haven't heard about this, this is like once again how it works. So it's like Koronavilkku makes the phone some kind of like Bluetooth beacon. So it's like sending Bluetooth signal around it and sending out key codes, which are random numbers. And other phones running Koronavilkku are listening for those codes and saving them to their own internal database. Those internal databases are, of course, heavily encrypted and heavily safeguarded, so nobody is able to get any information about meeting other people from the phone. All this is done by the Google and Apple created exposure notification API. And it means because when it is made by Google and Apple, it is working so that it's reliable, it never turns off, and it doesn't suffer from the operating system power saving features and so on. This is the part we made. So for example, when the people are if they fall ill and they are telling it from the others, this means that this is the point where they are entering their opening code they are getting from the healthcare professionals, and then the phone is sending their own daily broadcasted keys to the backend server, which is sharing this to all other Koronavilkku users. And Koronavilkku is comparing the codes, and if it's finding people who have been nearby, it means that then it's able to send an alert. The measurement, how the Koronavilkku is deciding when to send the alert. In the public, it is often said that it is 2 meters and 15 minutes. In reality, it's not that simple. We have 4 different risk parameters that the phone is measuring. The Koronavilkku is measuring when doing the comparison of keys, and from these, it is deciding of whether the probability of coronavirus infection has happened or not. So for example, here is a simple example of people who are meeting each other in cafeteria, and another one is a carrier of coronavirus. Let's say that 3 days ago they met in the cafeteria and were sitting in tables next to each other while having a cup of coffee. And then the other person started having symptoms, had a positive test result and reported the infection. And this is when the other person's phone starts to doing measurement when it's received the keys of the other person. So first thing it is measuring is the distance. Distance is measured using the radio signal, and in reality we have 4 different levels of distance. So we do not have any kind of measuring stick of 2 meters or 1.5 meters or so on. We have 4 different actual values: far, medium, near, and immediate. And we are giving the risk points according to this one. For example, in cafeteria, we could define that, okay, people were in the medium distance from each other, and this gives us 2 risk points. Then there's the duration. So duration was, it's measured in the 5-minute resolution. And for example, if they have been near each other between 15 and 20 minutes, it means that they get 5 points for that one. Then we have an infection potential. This is when the person was getting their infection code. The healthcare professional interviewed them and asked, when did your symptoms start? And with this, they inputted the metadata to keys so that we are able to measure how infectious the person was. People are most infectious between 2 days before and 2 days after their symptoms started. And in this example, for example, this person was their most infectious, so it means they are getting 8 risk points. And then we still have the days since exposure. Currently, we are measuring 10 days time when doing the comparison, and that gives us 1 point. When we do the calculation, each of these are multiplied with each other, we get 80 points. And our current warning level is 72, which means that in this case, the risk assessment meant that the warning should be given. But for example, let's say if the distance would have been greater or the time being greater, they might not have received the warning, or otherwise, when these values vary, then we get different kinds of probabilities, and this means that when we are getting a warning or not getting a warning. Another way of measuring using the same kind of far, near, and immediate buckets is to calculate minutes when people are near each other. This is an answer to long time exposures, for example, within the same family, and for example, people who are traveling together. This is an actual case where two people were traveling in the ship together and they were sharing the cabin. And we get a book report that they didn't get a warning, and we were able to, with help of other EU countries, to find out the bug inside the EN system. And this is the way with Apple and Google how we were able to fix this thing with current parameters. So we are measuring the time people are between each other, but we are collecting time to buckets. So for example, during the time when people were sharing the cabin in the ship, they were collecting the minutes. And if the cumulative exposure minutes during one day exceeds a certain level, in our case, for example, 15 minutes, then we are also able to give out the warning, which is another way to measure the exposure. And these two ways are the ones Koronavilkku is using currently and is able to find out whether the probability of infection is high or is not. And then, of course, this is very tightly connected with Omaolo. Koronavilkku is doing the exposure checking, warning, and sharing the warning, but it's not a medical device. It's just an ordinary software. And then we have the medical device Omaolo, which is using the actual medical things like symptom evaluation, handling people's contact requests, and it also contacts the PIN code generator that is used by healthcare professionals and so on. A couple of words about design things we met during the design, which were, of course, sometimes funny, sometimes a little bit irritating, and so on. One was that we had to start designing even before we were able to start the programming, but at the same time, when we heard that we are going to make this software, our designers started immediately doing the design work. And like I said, all the design was made in-house. It was pure coincidence, actually, that the people in our graphic design actually look a little bit same as people, for example, with the Swiss COVID used in Switzerland. They both have purple shirts, and of course we already saw in Twitter jokes about people traveling despite the travel restrictions and then having the exposure and headache and so on. But the graphics were made in-house already before. In the June we started design, and that was one of the challenges, how to do the design for the thing you still don't actually know how it is working. But still, it went well. We had a good design, and it's still available in Koronavilkku. Another thing was that the exposure notification API, which is created by Apple and Google, it's not constant. It is changing all the time. Apple and Google are improving it and making new features for it, doing updates and so on. Usually it goes well, but we had a couple of times when we were really surprised when, especially Apple, who made big changes without telling others and broke down our software for a day or two. But we managed to, of course, to go through these difficulties too. But it made us careful. We had to be careful because there always could be something changing under us, and we have to be ready to move quickly if there are changes that are breaking things. For example, now we are preparing for a totally new version of exposure notification, which is created in Apple and Google. Most of the countries in Europe are in the same kind of process of improving the software to use even more complex exposure probability calculation. One thing was, of course, what the law says. So in many times our user-centered design process became law-centered design process because ministry law and the interpretation of the law tells us what to do. One of the examples we are hearing all the time is, for example, people are asking that why doesn't Koronavilkku give us information about the date of infection, the exposure? We are not able to tell that because the law in Finland and the interpretation of it says that for privacy reasons we cannot give out the date. So even if we would be able to give out the date, we are not allowed to do that. So we are not then telling it around. One thing was that how to work with medical devices. As said, Omala.fi is a medical device which have MDR processes and so on, which means that its updates and changes and so on, they are much slower than in quotation marks normal software. So there will be strict user authentication, and we have to be careful when using the APIs towards Omala and so on, because we are dealing with heavily regulated things in here. And it shows, for example, let's say translations and the language also used in Koronavilkku. We have to be really careful with that ones because we cannot just type out whatever comes to our mind. Everything has to be checked and made sure that the language is correct. At one point, we were making study of whether Koronavilkku should be used as a medical device, so that we could give, for example, information about exposure severity and so on. But we quickly came to the conclusion that the Koronavilkku is not specific enough. As you said before, the probability calculation is of course quite unspecific, and it's dependent of many different things that is out of our hands, like for example radio signals and so on, which means that Koronavilkku is not able to function as medical device, but instead is helping others and giving people information and telling them with the options they are able to have after the probable exposure. Trust is one of the main things in here, and especially in the beginning of the software, we were quite worried that will people trust us and will people download the software and start using that, because there was lots of mistrust going on. For example, one of the white hat hackers originally said that they will never use Koronavilkku. It is so worrisome that government is using those things. But after the programming, he changed his mind. We didn't ask him for this. This is like the spontaneous reaction, and he said that he recommends and is of course using the software because he really trusts us. When creating the software, of course, we needed professional users, which was a problem because it was a summer when we were creating the software and many people were in holiday. So the for example, when we needed test users or started to train people, it was a problem because they didn't even know that they will be users when they come back from holidays. So this gave us time schedule troubles too. And of course, when we are dealing with many different parties, it was like committee cooperation and home municipalities and compatibility with Kela and so on and so on. But luckily, the team was very professional in all ends, and we were able to quickly solve any problems we were having. Coronavirus itself also created funny things. For example, user tests that had to be done wearing a mask and disinfectant and maintaining social distance, which made it much more difficult than usual. Language, of course, as said before, was very important with this one, and it was very large process of handling the translations, but quality of text is very good, and we were taking part of the competitions of dealing with the clarity of language and so on. So where are we now? What's going on currently? The user statistics and things we are hearing from around the world is that Finland, our application has world-leading adoption and usage rate. So we get Google and Apple are saying that they are very impressed about our performance, and it's like many countries are contacting us and asking that how are you doing it? How are you getting so many people to download and use this software? We have about 40% of Finns using Koronavilkku currently. So there are 2.8 million unique devices that have installed the software. And of those, there are of course many duplicates and so on, but we have over 2 million active users every day who are contacting the background database. And for Finnish population, this is very impressive amount. Of course, because this is very highly privacy preserving, we are not able to get numbers of, for example, delivered exposure warnings and so on. But we do know that people who are moving onwards to Omaolo, we see every day we see people coming in, and hundreds of people are using the symptom functionality in Omaolo when they are coming Koronavilkku to there.
Okay, wrapping up, Sami. Last
yes, this is actually this is the last slide, or second to last slide. As said before, I wasn't the only one creating this. I would like to share the glory with other people. We had almost 40 people working with these ones, and these are the heroes of the Koronavilkku project, the dream team. And then I was asked to give an advertisement for the last slide. We have a current cybersecurity compliance white paper available in Solita, and I encourage all of you to go and download this white paper and read it, because it is a very interesting read. The URL is here, and I can later, for example, put it in the chat, this one. Okay, this was it.